Welcome to BDP ICP 12. This ICP is about Graphrames and Graphx. So here we are going to perform an analysis on the distributed collection of the data. The softwares that are required are Spark as well as Banditools as well as the IntelliJ with the Scala plugin. So for the initial setup, we have to create a project in Spark, like in IntelliJ, with the help of the Spark and Scala plugins, and then we have to include the dependencies that are required inside the build.spt. As you can see, then the main apart from the main dependencies, that is Spark or mlib and SQL, like the main dependencies that are added over here for this ICP are the Spark Graphx, Graphrames, and the resolver, and also the Graphrames library dependency. And this is the jar file that is downloaded from the Spark website. So after downloading this, we have to include it over here. So the next job is like this, coming to the main program of it. So the first one is like, after importing the necessary inputs, we have to create a Spark session, and the name of the Spark session that is created over here is Graphs. And the first question is like importing the data as a CSV file and creating the data frames directly on import, and then creating a graph out of the data frame that is created. So the first for this one, I have created two data frames, that is trips df, where I am importing the trip data.csv over here, and the next one is like station data frame, where I am importing the station data. Mm, and so into the data frame, and then I'm just printing the schema of both of them over here. So the first one is the schema of the trips, and the second one is the schema of the stations. So after doing this, after printing the schema, I'm just creating a view for both these data frames, name with the names of trips as well as the stations. So now the multiple stations are stored in n station, and multiple trips are stored in n trips, with the help of the SQL query. And so we are going to view the stations as well as the trips over here. So this is the data frame or the table for the stations, as well as this is the data frame or the table for the trips. And so after doing this, the second question is like, the concatenation of the columns. So for this, I'm just concatenating the two columns in one data set. So here, from the stations table, that is from this table, as you can see, there are lat and long columns. So I have tried to concatenate both these columns with the help of this query, that is select concat of lat long from the stations, and the output is going to be this one, where this both will be concatenated. Say this is the latitude and the longitude. So this is all about the concatenation. The next one is removing the duplicates and as well as renaming the columns. So for removing the duplicates, what we have done is like, we from the station table, that is n station represents the total stations that are stored from the station data frame. So from this, uh, 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 like, I have done both renaming the columns and removing the duplicates together, where I'm renaming the column ID, renaming the column name with ID, and I'm taking the distinct values also, which indicates that this will help to remove the duplicates, because if there are any values that are removing with respect to ID, since ID is a unique value, it's going to remove that duplicates, thereby printing the data without duplicates. So whereas for edges, coming to the trips table, for trips table we are just saving that start station as SRC as well as end station as DST, which indicates the uh, starting and the ending, like start and the destination. So after doing this, uh, so after doing this again, I'm just okay. After doing this, I'm just creating a graph frame with the vertices as well as the edges. Any time the graph frame will be created with the help of two data sets, two data frames. So here from we are creating the vertices from the stations data frame and edges from the trips data frame. So as you can see, um, uh, so the next question is the next question will be rem okay, after removing duplicates and removing columns, uh, the next question is like creating and printing the output data frame. So the output data frame over here will be this one, where we can see that the starting destination, the starting point was renamed as SRC as well as the ending point is renamed as DST. So you could we could see here that this is the table that is printed out of after that. So the next one is like the name is replaced as ID. So this is the another data frame. So the fifth question is output data frame. As you can see, these are the output data frames. The next one is creating vertices and show some vertices as well as show some edges. So this part of the code explains as like what are the vertices as well as the edges that are present. The first one is like from the as I told, like we are creating a data frame from the station vertices as well as the edges from the trip. So this is the station graph will be our final graph frame. So from this graph frame, we are trying to print out the vertices with the help of the command like that graph frame dot vertices dot count, where we are taking the distant count also, mm, and like edges as well, and the distant count of edges, and as well as the total number of uh, like n trips from the original data. So n trips dot count. So basically the idea behind this is like we are showing the vertices as well as edges over here. As you can see here, the total number of stations and the distance stations are going to match with each other, since we have removed all duplicates over here, as well as the trips also we have since we have removed all the duplicates, they are going to match over here. So from this we are going to show the vertices as well as the edges. Coming to the next part of it, the next part is like printing the vertex in and the vertex out. So here here we are getting the in and out degrees, and we are ordering them by descending order and limiting it to like nearly 5 vertices. So uh, here is the in degree, where we are getting the data of in degree over here, and here is after in degree followed by the out degree, where we could see that this is coming in descending order and limiting it to 5. The next one is like motif findings. So coming to the motif findings over here. mm, so here is this. In this code, we are just finding the motif as we are writing the pattern for the subgraph over here. As you can see, this is the subgraph that we have written as it goes from A to A to the product, and like again, like it goes from A to B, and again from B again it goes to A, and we are just displaying the possibilities like how it's going to happen. So here is the possibilities of like how it is happening. So from A it's going to E, as well as from E it's going to B, and then from B it's going to E2, as well as from E2 again it's going back to A. So this is the sequence like how it's happening. So this is the motor findings, and then next comes the stateful queries. So this code is like the the same motif if we are going to apply by carrying the state also, then it's going to be the stateful query. Here from A we are going to B and B to C and C again we are coming back to A. It's a cyclic thing that's happening along with the states, so it's going to be a stateful query. So here over here, so we'll just see the output, like how it's basically happening. So here we can see like from A it's going to be like A B B B C and C A. So the complete flow we can see over here for the stateful queries. The next part is like subgraph, where we are finding the path for the graph that we have mentioned, that like going from A to B. So it's going from A to B via E. So uh, it's going from A to B via E, and this is the flow, like how it goes, like from 50 Herberges to San Francisco, and then from, like these are all the things that are just passing from A to B via E. So this is the end of the ICP. Coming to the bonus questions, like first one is like displaying the vertex degree. So as you can see, this is the go for displaying the vertex degree, and here actually we are calculating, we are basically identifying the distant start stations and aggregation of that with the connecting count, and we are renaming the start station with the new name ID and the destination as well. We are just trying to find out the distant things, and we are just renaming it, and with the and we are trying to find out the connecting part of it. So uh, so the output of that one, uh, okay, the output of that one is this one, where okay we will be able to identify all the vertex that are coming, and this is the bonus question one. And the next one is like identifying the common destination. So here we are just identifying the common destination from the trips table, where we are just identifying the destination and the count of the destination over here. Mm, so So here is the output for that one, where we are finding the destination and the count of the destinations, which will have the common destination. And the next one is identifying the in degree as well as the like high in degree as well as the out degree. So high in degree and out degree. So for that one, um, so um, So here is the in degree and the out degree part, where we are trying to find out the in degree and out degree, and we are just trying to find out that in degree and out degree from I, and like where based on the map of the ID, and we are limiting it to one in the descending order, and this is the ID of that thing, where we are this code, we are selecting the degree, and we are joining them with the inclusion of the IDs. Then we are just ordering them in the descending order, and then I'm just displaying it. So this is the basically the ID of that one. And the fifth bonus question is like saving the graphs that both like the station graph vertices as well as the indexes. So this is, I'm just saving it as vertices as well as edges, and it is saved here only. So so as you can see, the edges has come up here and the vertices has come up here, which has got all the files. It's in CSV format. It has got all the files. So yeah, this